GMAT all day.
This next question I have labeled as a VIC question. VIC stands for variables in the answer choices, which means if you look at your answer choices, instead of containing numbers, they have variables. So VICs are usually pretty easy to recognize. They like asking VICs. VICs are not specific to rate questions. They like asking them with percent questions. They ask them with probability questions a lot. And I think really what they're doing with VICs are more of a subtype of question than they are a question type itself. And it is one way that the GMAT test writers, they can take an easy or medium difficulty level question and convert it into a hard question. They simply take out the numbers and replace them with variables, because when they do that, they are decreasing the chance that someone can just plug in the numbers that they give you and accidentally stumble upon the right answer. You really need to understand the underlying concept when you are doing VIC questions. And so the first thing that I need to decide whenever I see a VIC question is, how do I want to do it? And there are really only two strategies. Do I want to do it algebraically or by testing numbers? And my preference is usually to do algebra, because when I am doing algebra, I am proving the answer to myself. In other words, I am translating the statements from the prompt, and then I am trying to come up with an expression on paper that exactly matches the right answer. Whereas when you are testing numbers, you are coming up with the example set of numbers for the variables that they give you, and then you have to plug those into each of the answer choices until you get an output that matches whatever the actual solution is to your question. And so testing numbers, usually it can take longer. It is also more prone to math mistakes. So algebra is usually my preference, but I am certainly testing numbers often. And I do think that testing numbers is a very valuable skill on the GMAT. A lot of people, especially as they get farther into their studies, I think they start thinking that algebra is the only way of doing something. And if you are testing numbers, you are doing it the wrong way. And I certainly do not believe that. I think testing numbers, I do it all the time. And oftentimes it is either the only way of doing something or the more efficient way of doing something. And so I guess the ideal situation is know how to do it both ways, and then you can choose which way works for you. And so when can I do these VIC questions algebraically? Well, usually it is when I get a VIC question that is a type of question that I'm used to doing algebraically. So things like rates or percents or probability, I'm used to doing those types of questions algebraically. So I can usually do that with when they give those as VICs. And so for this question, maybe we will do it. We'll make two videos, once doing it algebraically and once doing it testing numbers. Because in order to do something algebraically, you have to have a strategy for how you're going to do that. You have to know how you are going to translate your statements into algebra. So testing numbers really sort of becomes the default option if you can't do it algebraically. And so even if algebra is your preference, well, you probably shouldn't be doing it if you don't have a path forward. So let's see how we would do this one algebraically first, and then in the next video, I'll make one testing numbers. Felix can build a fence in X days. Oscar can build 1/3 of the same fence in Y days. Together, they can build 2 fences in Z days. What is Y in terms of X and Z? So by that, they mean they want you to imagine that all of your answer choices have a left side over here just saying Y equals. Then they want Y in terms of X and Z. And so if I'm doing this algebraically, I'm really not doing anything that is that different than what I've been doing for all the other rate questions. I just have to think a bit about how I want to express the information given. But to start, I got 3 players, Felix, Oscar, and then we have Felix and Oscar. And then it says Felix can build a fence in X days. So just like in the previous question, when I read this, I don't think of this as being a time, even though days is a unit of time. I think of this as a rate. It is Felix's individual rate, and our work is in terms of fences, and so his rate is 1 fence per X days. Oscar can build 1/3 of the same fence in Y days. So same thing here. This is also a rate. This is just Oscar's rate, but don't let this fraction throw you off. If you just think of rate just has 2 components, it's got a work component on top and a time component on the bottom. Well, then they are just saying he can do 1/3 of a fence, so that is his work component, every Y days. So Oscar's rate is just 1/3 of a fence per Y days. And so if you want to simplify this now, you can, just using your knowledge of dividing fractions. So when I divide a fraction by a variable, it is the same as multiplying by 1/, so 1/3 divided by Y is the same as 1/3 times 1/Y, which is just 1/3Y. So the units here are the same. So this is saying 1/3 of a fence per every Y days is the same as one fence every 3Y days. And so if I want to express Oscar's rate that way, I can, and I will. 1 fence every 3Y days. And then together they can build 2 fences in Z days. So that is their combined rate. 2 fences per Z days. And so far we have been usually expressing our rates in terms of completing one job or one warehouse. It is perfectly fine to have it in terms of 2 fences in this case. So even though now I filled in my chart, and I got to think now about the question, even though the question says that I want Y in terms of X and Z, my real goal, at least my initial goal in terms of the next step, isn't to get Y in terms of X and Z. I just want any equation that contains a Y, an X, and a Z. Because if I could just make any equation involving a Y, X, and Z, well, then I can just rearrange it to get Y by itself. And so here, just like in our other, this is just really a combined rate question. And therefore, just like in the other ones we did, the sum of their individual rates should be equal to their combined rates. And that is my equation. So 1/X plus 1/3Y should be equal to 2/Z. Now I just need to get Y by itself. So to start, I will just move the X over here. So subtract 1/X from each side. Now I want to combine my fractions on the right side. So how do I do that here? So usually we need a common denominator, and usually when you are trying to get a common denominator, you are looking for the least common multiple between your two denominators. You don't really have a least common multiple when you have variables, and so your only choice in order to get a common denominator is just to multiply the two. So our common denominator here would be Z times X, meaning I have to multiply this guy here by X/X, and this guy here by Z/Z. And so I get 2X over ZX minus Z/ZX, which leaves me with 1/3Y is equal to 2X minus Z all over ZX. So now I need to focus on getting a Y equals, not 1/Y. So to start, I want to just move this 1/3 over. I'll just multiply each side by 3. And that leaves me with, that gets rid of the 1/3, but I still have a 1/Y on the left side, because this is really just 1/3 times 1/Y. So I multiply it by 3. All I'm really doing is canceling out this 3 here. So I still have 1/Y here is equal to 6X minus 3Z all over ZX. And so I want to get everything in terms of just Y. So if 1/Y is equal to this, Y should be equal to just the reciprocal. So Y is equal to ZX over 6X minus 3Z. And the final step in a VAC question is sometimes you just have to format or simplify your equation the way they want it. And so sometimes you have to glance at the answer choice, but this should be right. As long as we did not make a math mistake, we might have to factor out this 3 here, but it should be mathematically correct. So ZX over 6X minus 3Z, which is the same as XZ over 6X minus 3Z. The answer choice here is A.